In the infinite darkness of space lies a cosmic dance of extraordinary wonder, a journey beyond imagination. 4.6 billion years ago, in a remote arm of the Milky Way, a massive cloud of gas and dust began to collapse. At its center, intense pressure and heat ignited a nuclear furnace. Our Sun was born. This newborn star, containing 99.8% of all mass in our system, sent powerful solar winds outward, clearing the surrounding space of debris. What remained began to clump together, guided by gravity's invisible hand. From this cosmic dance, 8 planets emerged. Mercury, closest to the Sun, where temperatures soared to 800 degrees Fahrenheit. Venus, shrouded in toxic clouds, trapped in a runaway greenhouse effect. And Earth, a blue oasis, perfectly positioned for liquid water and life. Mars, the red planet, once flowed with rivers and lakes. Jupiter, the king of planets, so massive it could fit 1,300 Earths inside. Saturn, crowned with magnificent rings, spanning 175,000 miles wide. Uranus, tipped on its side, rolling like a barrel through space. And Neptune, where winds howl at 1,200 miles per hour. Between these worlds lies the asteroid belt, remnants of a planet that never formed. Beyond Neptune stretches the Kuiper belt, home to countless icy bodies and dwarf planets like Pluto. Our solar system is a cosmic clockwork. The planets orbit in nearly perfect circles, all in the same direction, in almost the same plane, like a giant disk. This is no accident. It's the signature of their shared violent birth. Each planet tells a unique story. Earth's moon was born from a collision with a Mars-sized object. Mercury's surface is scarred by countless impacts. Jupiter's great red spot has been raging for at least 400 years. Even now, our solar system continues to evolve. Comets streak across our skies. Asteroids make close passes by Earth, and the Sun slowly grows brighter. In 5 billion years, it will swell into a red giant, engulfing the inner planets. This is our cosmic neighborhood, a testament to the raw power of gravity and the endless cycle of creation and destruction that shapes our universe. In its scale, we find humility. In its complexity, we find wonder. And in its existence, we find our place in the cosmos. At the heart of our solar system burns an eternal engine of incomprehensible power. Our Sun, a colossal sphere of plasma born from the cosmic debris of ancient supernovas nearly 5 billion years ago. In the beginning, gravity pulled hydrogen and helium together, creating immense pressure at its core. When the temperature reached 15 million degrees Celsius, nuclear fusion ignited. The same process continues today, converting 400 million tons of hydrogen into helium every second. The Sun's core is a furnace of extreme physics. At its center, atoms are crushed together with such force that they merge, releasing energy in the form of light and heat. This energy slowly travels outward through the radiative zone, taking up to 170,000 years to reach the surface. The Sun's surface, or photosphere, churns like a pot of cosmic soup. Massive convection cells, each larger than Texas, carry hot plasma to the surface and sink back down. This creates the distinctive granular pattern we observe through specialized telescopes. But the Sun's activity doesn't stop at its surface. Solar flares, explosive releases of magnetic energy, can eject billions of tons of material into space at millions of miles per hour. These coronal mass ejections, when directed at Earth, can disrupt satellites and power grids. Our star's magnetic field goes through an 11-year cycle. from periods of intense activity to relative calm. During solar maximum, sunspots pepper the surface like dark freckles, each a window into the complex magnetic processes occurring beneath. The sun's influence extends far beyond its visible surface. Its gravitational pull keeps planets in orbit, while its solar wind creates a protective bubble around our solar system, the heliosphere. This cosmic shield helps protect us from dangerous galactic radiation. In about 5 billion years, our sun will begin to die. Having exhausted its hydrogen fuel, it will expand into a red giant, eventually shedding its outer layers to become a white dwarf. But for now, it remains the stable, life-giving heart of our solar system. Every second of every day, this cosmic engine provides the energy that powers life on Earth. From the food we eat to the wind that blows and the rain that falls, all are gifts from our extraordinary star. The sun isn't just the center of our solar system, it's the foundation of our existence. In the scorching embrace of our sun lies Mercury, a world of extremes where metal melts and ice survives. This is the story of our solar system's smallest planet, yet one of its most fascinating mysteries. Born in violence 4.6 billion years ago, Mercury emerged from the same cosmic cloud that gave birth to our entire solar system. But something set it apart. This tiny world, only slightly larger than our moon, became the densest planet next to Earth, with a massive iron core that makes up an astounding 60% of its volume. Mercury lives a life of contradictions. Its days are scorching, reaching 800 degrees Fahrenheit, hot enough to melt lead. Yet in its deepest craters, hidden from the sun's relentless gaze, scientists have discovered ice, preserved in permanent shadow. The planet's surface tells a tale of cosmic bombardment. Countless impacts have scarred Mercury's face, creating a landscape that resembles our moon. The largest of these scars is the Caloris Basin, an impact crater large enough to fit the state of Texas inside it. But Mercury holds more surprises. Despite being the closest planet to the Sun, it's not the hottest. That title belongs to Venus. Mercury's lack of atmosphere means that heat quickly escapes into space during its long nights, causing temperature swings of over 1,100 degrees Fahrenheit. In its rapid orbit, Mercury races around the Sun every 88 Earth days. Yet its day lasts twice as long as its year. This cosmic dance creates unique patterns of sunrise and sunset that would appear alien to Earthbound observers. The planet's proximity to the Sun has warped space-time itself, causing Mercury's orbit to shift slightly with each pass, a phenomenon that helped prove Einstein's theory of relativity. Recent missions like MESSENGER have revealed Mercury's magnetic field, mysterious hollows that seem to be actively forming, and evidence of recent volcanic activity. These discoveries challenge our understanding of how planets evolve and survive in the extreme conditions near a star. As we continue to study this remarkable world, Mercury reminds us that even in our cosmic backyard, there are still mysteries waiting to be uncovered. It stands as a testament to the incredible diversity of our solar system and the surprising ways planets can adapt to even the most extreme conditions in space. In the vast expanse of our solar system lies a world shrouded in mystery and danger. Venus, Earth's infernal twin. Born from the same cosmic debris as Earth 4.6 billion years ago, Venus took a dramatically different path. This scorched world, perpetually veiled in thick, toxic clouds, holds a dark secret. Its atmosphere, 90 times heavier than Earth's, creates a runaway greenhouse effect so extreme that its surface temperature could melt lead. At 864 degrees Fahrenheit, It's hot enough to destroy most spacecraft within hours. But Venus wasn't always this way. Scientists believe that billions of years ago, Venus might have harbored vast oceans and conditions similar to Earth. What transformed this potentially habitable world into a hellscape? The answer lies in its slow rotation. A day on Venus lasts longer than its year. Beneath its golden clouds of sulfuric acid lies a landscape of volcanic plains, stretching as far as the eye can see. Massive shield volcanoes dot the surface, some potentially still active. The intense atmospheric pressure at the surface is equivalent to being nearly a mile deep in Earth's oceans. Despite these extreme conditions, Venus continues to captivate scientists. Its super-rotating atmosphere, where winds blow up to 60 times faster than the planet's rotation, remains one of our solar system's greatest mysteries. These winds drive the planet's iconic Y-shaped cloud patterns, visible even from Earth. Perhaps most intriguingly, high in Venus's atmosphere, where temperatures and pressures are more Earth-like, scientists have detected traces of phosphine, a possible signature of microbial life. Could life exist in the clouds of our sister planet? As we continue to explore this fascinating world, Venus teaches us a profound lesson about climate change and planetary evolution. This scorched planet serves as both a warning and an inspiration, a reminder of how precious and unique our own world is, and how delicate the balance of life can be. Venus, a world of extremes, where Earth's past or possible future may be written in clouds of acid and rivers of molten rock. As we look to the stars for new homes, our infernal twin reminds us that paradise can be lost. But perhaps, somewhere in those golden clouds, new mysteries await discovery. In the vast expanse of our cosmic neighborhood, there exists a remarkable anomaly, a blue marble suspended in the darkness of space. This is Earth, our home, and its story begins 4.6 billion years ago. Born from cosmic violence, Earth emerged from a cloud of gas and dust, gradually forming through countless collisions. As gravity pulled matter together, our young planet became a molten sphere of chaos. Then came an impact that would define our world. A collision with a Mars-sized object that created our moon, Earth's constant companion. But what makes Earth truly extraordinary is what happened next. As the planet cooled, water vapor condensed into vast oceans. Our atmosphere formed, creating a protective shield against harsh cosmic radiation. Deep beneath the surface, powerful forces began shaping our world through plate tectonics, building mountains and carving valleys. Earth is a masterpiece of natural engineering. Its magnetic field, generated by our planet's molten core, deflects harmful solar winds. The atmosphere, a delicate blend of gases, creates the perfect conditions for life. Our oceans, covering 71% of the surface, regulate temperature and drive weather patterns across the globe. Life itself emerged in Earth's primordial seas about 3.5 billion years ago. Through countless iterations of evolution, simple single-celled organisms gave rise to all the diversity we see today. From the deepest ocean trenches to the highest mountain peaks, life has found a way to thrive. Every day, Earth performs an intricate ballet. It spins on its axis at over 1,000 miles per hour, creating our day and night cycle. It orbits the Sun at 67,000 miles per hour, tilted at precisely 23.5 degrees, the perfect angle to give us our seasons. Our planet is a complex system of interconnected cycles. Water evaporates from oceans, forms clouds, falls as rain, and flows back to the sea. Carbon cycles through the atmosphere, oceans, and living things. These delicate balances have maintained Earth's habitability for billions of years. Yet Earth is not static. It breathes through volcanic eruptions, shifts through earthquakes, and transforms through erosion. Every moment, somewhere on our planet, new rock is being formed while old rock is being worn away. Rivers carve canyons, glaciers sculpt valleys, and winds shape deserts. This is our home, unique, dynamic, and irreplaceable. A planet that took billions of years to become what it is today. A world that harbors millions of species, including us, its conscious observers. Earth, our living planet, still writing its story in the cosmic ocean. In the cold expanse of our solar system, a crimson jewel beckons humanity's imagination. Mars, the red planet, a world of extreme contrasts and ancient mysteries. Born over 4.6 billion years ago from the same cosmic dust that formed Earth, Mars emerged as a smaller but equally dynamic world. Its distinctive red color, visible even to ancient civilizations, comes from iron oxide, the same compound that creates rust on Earth. Mars tells a tale of lost potential. Billions of years ago, it possessed a thick atmosphere and flowing water. Vast oceans once covered its northern hemisphere, while rivers carved deep canyons into its surface. But something changed. The planet's magnetic field weakened, allowing solar winds to strip away its protective atmosphere. Today, Mars stands as a frozen desert world. Yet its features are nothing short of magnificent. Olympus Mons, the largest known volcano in our solar system, rises 3 times higher than Mount Everest. The Valles Marineris, a canyon system that would stretch across the entire United States, plunges 7 times deeper than the Grand Canyon. Mars's polar ice caps, composed of both water ice and frozen carbon dioxide, expand and contract with the changing seasons. During winter, temperatures plummet to minus 140 degrees Celsius. In summer, they can rise above freezing, creating brief moments where liquid water might exist on the surface. The planet's 2 moons, Phobos and Deimos, are likely captured asteroids, too small to form perfect spheres under their own gravity. Phobos orbits so close to Mars that it appears to rise in the west and set in the east, twice each Martian day. Despite its hostile environment, Mars continues to intrigue scientists searching for signs of past or present life. Beneath its rusty surface, underground lakes of liquid water may still exist, protected from the harsh surface conditions. Each new discovery brings us closer to understanding this enigmatic world. As we stand on the brink of becoming an interplanetary species, Mars represents our first step into the cosmos. This red world, once as vibrant as our own, now waits silently, perhaps for us to wake it from its long, cold slumber. Between Mars and Jupiter lies one of our solar system's most fascinating features, a vast cosmic dance of rocky bodies known as the asteroid belt. But how did this celestial highway of debris come to be? 4.6 billion years ago, during the formation of our solar system, Jupiter's massive gravitational influence prevented these rocks from coalescing into a planet. Instead, they were left to orbit the Sun in this cosmic ring, like remnants of a world that never was. Within this belt of millions of asteroids, 2 objects stand out: Ceres and Vesta. Ceres, the largest object in the asteroid belt, is so massive it comprises 1/3 of the belt's total mass. This dwarf planet spans 940 kilometers in diameter, large enough to be rounded by its own gravity. In 2015, NASA's Dawn spacecraft revealed Ceres' secrets: a world of bright salt deposits, mysterious bright spots, and evidence of an ancient underground ocean. Perhaps most intriguingly, scientists discovered organic molecules on its surface, hinting at the potential for primitive life building blocks. Then there's Vesta, the belt's second largest resident. This protoplanet is a testament to the violent history of our solar system. Its surface bears the scars of massive impacts, including a colossal crater at its south pole that nearly shattered it completely. Vesta's composition tells us a remarkable story. It's one of the few asteroids visible to the naked eye from Earth, thanks to its highly reflective surface. Scientists believe it represents one of the earliest solid bodies to form in our solar system. The asteroid belt isn't just a cosmic junkyard, it's a scientific treasure trove. These ancient rocks are time capsules, preserving the conditions of our early solar system. Some even contain water ice and organic compounds, potentially holding clues to the origins of life on Earth. Today, as our technology advances, we continue to uncover new mysteries within this celestial highway. Each discovery in the asteroid belt brings us closer to understanding not just our solar system's past, but perhaps humanity's future among the stars. In the cold depths of our solar system, a giant churns through space. Jupiter, a colossus so massive it could swallow 1,000 Earths. This is the story of our solar system's undisputed king. Born 4.6 billion years ago in the swirling chaos of our early solar system, Jupiter grew rapidly, consuming vast amounts of gas and dust. Its immense gravitational pull was so powerful that it nearly pulled our young solar system apart. Today, this gas giant spins faster than any other planet, completing a full rotation in just 10 hours. Jupiter's atmosphere is a violent masterpiece. The Great Red Spot, a storm larger than Earth itself, has been raging for at least 400 years. Bands of white, brown, and red clouds race around the planet at speeds exceeding 400 miles per hour, creating a hypnotic dance of cosmic proportions. But Jupiter isn't alone in its celestial dance. It commands an empire of 79 known moons. The 4 largest, discovered by Galileo himself, each tell a unique story. Io, the most volcanic world in our solar system, where sulfuric lakes bubble beneath a technicolor surface. Europa, with its icy shell hiding a vast liquid ocean beneath. Ganymede, the largest moon in our solar system, bigger even than the planet Mercury. And Callisto, bearing the scars of countless impacts across its ancient surface. Jupiter's magnetic field is the strongest of any planet, stretching millions of miles into space. If visible to the human eye, it would appear larger than our moon in Earth's sky. This magnetic monster creates spectacular auroras at its poles, dwarfing Earth's northern lights. The planet's influence extends far beyond its immediate vicinity. Like a cosmic shepherd, Jupiter's gravity protects Earth from countless asteroids and comets, earning it the nickname vacuum cleaner of the solar system. Without Jupiter's protective presence, life on Earth might look very different, if it existed at all. As our technology advances, we continue to uncover Jupiter's secrets. NASA's Juno spacecraft has revealed stunning details about the planet's composition and interior structure. We now know that Jupiter's iconic stripes extend thousands of miles deep, and that its core might be larger and more diffuse than we once thought. Jupiter remains both a guardian and a gateway, marking the boundary between the inner rocky planets and the outer gas giants. It stands as a testament to the raw power and beauty of our cosmic neighborhood, reminding us that even in the vastness of space, we are connected to something greater than ourselves. In the vast expanse of our solar system, one planet stands as nature's cosmic masterpiece: Saturn. Born over 4.5 billion years ago from the same cosmic dance that created our sun, this gas giant emerged as something extraordinary. At first glance, Saturn appears deceptively simple: a sphere of hydrogen and helium, painted in bands of gold and amber. But this simplicity masks a world of incredible complexity. Its atmosphere rages with storms that dwarf our entire planet. At its core, pressures are so intense that hydrogen becomes metallic, conducting electricity like copper wire. But Saturn's true glory lies in its rings. These aren't solid structures, but rather billions of ice particles, rocks, and cosmic dust, each orbiting like a tiny moon. Some as small as a grain of sand, others as large as mountains. Together, they form a disk so thin that if you could shrink Saturn to the size of a CD, its rings would be thousands of times thinner than a sheet of paper. Yet Saturn is far from alone. It reigns over a family of more than 80 known moons, each with its own remarkable story. There's Titan, larger than the planet Mercury, with its thick atmosphere and liquid methane seas. Enceladus, an icy world shooting geysers of water into space. And Mimas, whose giant crater makes it look uncannily like the Death Star. Through the eyes of spacecraft like Cassini, we've witnessed Saturn's seasonal changes as its rings tilt toward and away from our sun. We've seen how its magnetic field dances with the solar wind, creating auroras that dwarf Earth's northern lights. We've watched as its moon, Prometheus, carves elegant patterns in its rings, like a cosmic sculptor. But perhaps most fascinating is what Saturn tells us about our own origins. Its composition mirrors that of the early solar system, preserving a record of the cosmic ingredients that would eventually give rise to all we know. Every ice crystal in its rings, every swirl in its atmosphere, every moon in its orbit. They're all pages in the story of our cosmic neighborhood. As our technology advances and our understanding deepens, Saturn continues to surprise us. It reminds us that even in an age of remarkable scientific achievement, there are still mysteries waiting to be unraveled in the shadows of its rings. In the vast expanse of our solar system, 1.8 billion miles from Earth, floats a world shrouded in mystery. Uranus, the sideways planet. This ice giant, 4 times wider than Earth, harbors secrets that have puzzled astronomers for centuries. Born 4.5 billion years ago from the same cosmic dance that created our solar system, Uranus emerged as something unique. Unlike its planetary siblings, this massive world lies tipped on its side, rotating at a bizarre 98-degree angle, as if some ancient cosmic collision knocked it off its feet. Beneath its serene blue-green exterior lies a story of extremes. The planet's atmosphere, a turbulent mix of hydrogen, helium, and methane, creates its distinctive color. But don't let its peaceful appearance fool you. Wind speeds can reach a staggering 560 miles per hour, whipping through layers of clouds in an endless cosmic dance. Uranus holds another surprise: its temperature. Despite being farther from the Sun than Saturn, parts of its upper atmosphere can unexpectedly reach a scorching 1070 degrees Fahrenheit. Yet its core remains a frigid negative 371 degrees Fahrenheit, earning it the title Ice Giant. The planet's peculiarities extend to its magnetic field, which tilts at 60 degrees from its rotational axis. This creates a complex magnetic environment, unlike anything else in our solar system, leading to unique aurora displays that dance across its poles. Uranus isn't alone in its cosmic journey. It commands a court of 27 known moons, each named after literary characters from the works of Shakespeare and Alexander Pope. These moons, along with 13 distinct rings, form a complex system that continues to intrigue scientists. Perhaps most fascinating is Miranda, Uranus's 5th largest moon. Its surface is a bizarre patchwork of features: deep canyons, terraced layers, and mysterious dark patches that suggest a violent past of destruction and reassembly. As our technology advances, we continue to uncover new mysteries about this distant world. Each discovery about Uranus helps us better understand not just our solar system, but the countless others we're finding throughout the galaxy. In the end, Uranus stands as a testament to the incredible diversity of our cosmic neighborhood. It reminds us that in space, reality often surpasses our wildest imagination. In the cold, dark reaches of our solar system, where sunlight barely whispers, lies a world of striking beauty and fascinating mysteries. Neptune, the eighth and farthest known planet from our Sun, born 4.5 billion years ago from the same cosmic dance that created our solar system. Neptune emerged from a swirling disk of gas and dust. But unlike its rocky siblings, closer to the Sun, Neptune grew into something far more exotic. An ice giant. At nearly 4 times Earth's diameter, Neptune is a colossal sphere of water, ammonia, and methane ices, wrapped in a thick atmosphere of hydrogen and helium. Its signature blue color comes from methane gas absorbing red light and reflecting blue, creating one of the most beautiful sights in our cosmic neighborhood. Neptune's discovery tells a remarkable story of human ingenuity. In 1846, mathematicians Urbain Le Verrier and John Couch Adams independently predicted its existence purely through calculations, noting unexplained movements in Uranus's orbit. When astronomers pointed their telescopes to where the mathematics suggested, there it was, a triumph of scientific prediction. The planet's atmosphere is one of the most dynamic in our solar system. Winds here scream at speeds up to 1,200 miles per hour, the fastest planetary winds detected in the solar system. These supersonic winds drive storms across Neptune's face, including the famous Great Dark Spot, a massive storm system as large as Earth itself. Below its turbulent atmosphere lies an ocean of exotic ice, not the kind we know on Earth, but a super dense form of water that exists under extreme pressures. Scientists believe it might even rain diamonds in Neptune's atmosphere, as methane gets compressed into diamond crystals that fall toward the planet's core. Neptune takes 165 Earth years to complete one orbit around the Sun. Its seasons last for decades, and its days fly by in just 16 Earth hours. The planet's rapid rotation causes its magnetic field to tilt 47 degrees from its rotational axis, creating one of the most complex magnetic environments in our solar system. Among Neptune's 14 known moons, Triton stands out. This frozen world, likely captured from the Kuiper Belt, orbits backward compared to Neptune's rotation, the only large moon in our solar system to do so. Its surface, marked by nitrogen geysers and cryovolcanoes, hints at possible subsurface oceans. As our technology advances, we continue to uncover new mysteries about this distant world. Each discovery reminds us that even at the edges of our solar system, nature crafts wonders that challenge our imagination and understanding. Neptune remains a testament to the incredible diversity of our cosmic neighborhood and a reminder that there's still so much left to explore in the vast ocean of space. Beyond the familiar planets of our solar system lies a mysterious realm of ice and rock, a cosmic graveyard of failed planets and ancient debris. This is the Kuiper Belt, a vast ring of primordial objects that hold secrets from our solar system's birth. Discovered in 1992, the Kuiper Belt spans a region 20 times wider than the distance between Earth and the Sun. Within this cosmic wilderness, millions of icy bodies orbit our star, each a frozen time capsule from the dawn of our solar system. At the heart of this story lies Pluto, once considered our 9th planet. Now we know it as the king of the Kuiper Belt, the largest of its dwarf planets. When NASA's New Horizons spacecraft reached Pluto in 2015, It revealed a world far more complex than anyone imagined. Pluto's surface is a canvas of surprises. Vast plains of nitrogen ice, mountains of water ice as tall as the Rockies, and a heart-shaped region that's become its most famous feature. But Pluto isn't alone. It dances through space with 5 moons, including Charon, so large that Pluto and Charon orbit a point between them. The Kuiper Belt itself formed over 4.6 billion years ago, when our solar system was young. As planets emerged from the cosmic debris, they scattered countless smaller objects into this distant region. Today, these objects range from tiny rocks to worlds hundreds of miles across. This region is also home to some of our solar system's most peculiar orbits. Many Kuiper Belt objects, including Pluto, circle the Sun in paths that tilt dramatically from the plane where planets orbit. Some even loop backward, telling tales of ancient cosmic collisions and gravitational battles. Scientists believe the Kuiper Belt holds clues to how Earth got its water, how planets formed, and perhaps even the origins of life itself. Each icy body is a preserved sample from our solar system's infancy, waiting to tell its story. As our technology advances and our reach extends further into space, we continue to uncover new mysteries in this distant realm. The Kuiper Belt reminds us that even in our own cosmic backyard, there are still frontiers to explore, secrets to uncover, and wonders to behold. At the very edge of our solar system, far beyond the familiar planets and asteroids, lies a mysterious realm that few have heard of. Yet it shapes the destiny of countless comets. This is the Oort cloud. Picture a giant spherical shell of icy bodies surrounding our entire solar system, stretching nearly halfway to the nearest star. This vast cosmic halo contains trillions of objects, each a frozen time capsule from the birth of our solar system. But how did it form? 4.5 billion years ago, as our solar system emerged from a swirling disk of gas and dust, not everything found its place in neat orbital paths. Gravitational forces from the giant planets ejected enormous amounts of material outward, creating this distant reservoir of ice and rock. The Oort cloud is so far away that light from the Sun takes over a year to reach its inner edge. Its outer boundary extends up to 3 light years away, a distance so vast that the Sun's gravity barely holds onto these objects. To put this in perspective, if the Sun were the size of a marble, the Oort cloud would extend for several kilometers in every direction. Within this cosmic deep freeze, countless comets lie dormant. But occasionally, something disturbs their ancient slumber. Perhaps a passing star's gravitational pull, or the slow drift of our galaxy through space. These disturbances can send comets plunging toward the inner solar system, beginning journeys that might last millions of years. The Oort cloud remains one of astronomy's most intriguing mysteries. We've never directly observed it. Its contents are too small and too far away for our current telescopes. Yet, we know it exists through the comets it sends our way, like cosmic messages in bottles from the edge of our solar neighborhood. This vast sphere of ice and rock serves as a boundary between our solar system and interstellar space, a reminder that even after centuries of astronomy, our cosmic backyard still holds secrets waiting to be discovered.